Alright guys, a quick lesson on chain rule and trig, and just a quick reminder about the chain rule. I found this somewhere and I thought it was really good. When do we need to use a chain rule and when we do not need to use a chain rule. So if you have something like this, just a regular polynomial, in this case quadratic, you don't need it. But if you have a somehow composition of a function, that's where you would use a chain rule. This one, sine of x, you don't need to use the chain rule. You know what the derivative of sine of x is. But if you have a sine of a double angle, then you need to use a chain rule because there's something going on right there. Again, 3x minus 2, but if you have an expression that is raised to some power that we really do not want to multiply, definitely a chain rule. And look at this one, a similar example as this one, where you have a tangent of x and this is a tangent of x squared. If you have something like this, chain rule is recommended. All right, what was the chain rule? We've done it a few days ago. So when you have a chain rule, you are going to find the derivative of the outside function and leave the inside function alone. Again, it's a little bit different way of saying the same thing that we have, and then you multiply it by the derivative of the inside function. So let's look at some fairly basic example that will include the trig, and then we are going to go back to chain rule in general. So let's see, my first example is cosine of right here, cosine of 5x, and that is squared. So we need to think about what is to be done. And again, we talk about this, or I talk about this for a second. Well, I don't want this square to be here. I am actually going to change it. The square we'll put right there. I wrote this incorrectly, or not like the way I wanted to. This would be a different story. So if I have cosine of 5x squared, notice that I am going to take my, and again careful here with notation, my cosine of x is going to be my f of x function, and my g of x function will be what is inside. Derivative of the cosine function. Derivative of cosine function is negative sine of x. And derivative of 5x squared is going to give me 10x to the power of 1. And now if I put this all together, so again, a little bit of notation problem here, but that's okay. So derivative of this function in general is going to be negative sine of, we are going to put the 5x squared right inside. We are leaving that alone. And we are going to multiply this by the derivative of the inside, which is 10x. And we'll clean it up a little bit, so I will have negative 10x sine of 5x squared. And now I am done with this one. I have another one that will have a trig involved. And this one, well, do you need to do the composition of the function? Maybe, maybe not. I will because I want to. So keep in mind that this is also can be written as sine of x squared. So what are we going to do? I am going to say that my function f of x is going to be x squared, and my g of x is going to be sine of x. So if I plug this inside to this one, I would have sine of x squared. So now the derivative of f function is going to give me 2x, and the derivative of the g function is going to give me derivative of sine is equivalent to cosine. Again, we proved this the other day. And now if I put it all together, I am going to have 2 sine of x, I am plugging this in place of x function, times derivative of the g function, which is cosine of x. You will see when you're actually in class and doing this in class, you will see what it means graphically. We could make graphs of this and it will have great meaning, but that's something you will do in the future. All right, that's it. Derivative of the sine squared is 2 sine of x cosine of x. I have 2 examples on this paper. Well, I am going to copy them on your work paper. On your practice, we've done those, but it's a little bit more. And I do have, and for tomorrow, I will give you an assignment that is going to be a challenge, that is going to be something that I did not necessarily explain. So after having you do those, so kind of showing you what is the idea, again, kind of on purpose, I am going to give you something more difficult for the homework assignment. So again, you can ignore this here as the notes. I am going to put this on a separate piece of paper and come see me if you need any help, or try to explore it and have fun with it, as always.